Okay, so this is going to be the first word problem that we've looked at where we combine more than one vector together. What I want to point out as we go through these is that if you followed along with previous videos and kind of how to work with vectors, how to break them down into their component forms, how to add more than one vector together, what you're going to realize is that these word problems, at least the ones that I'm going to share and show, tend to be pretty straightforward if you think about them just as fluffy versions of the previous problems. And what I mean by that is that while this is technically what we would consider a word problem, there's a lot of words here, very few numbers, it's really just wording out the same stuff we've been doing before. Notice it says find the magnitude and direction of two forces. So in the past we just said find magnitude and direction. We cut out the two forces statement. We didn't use units in our previous videos, we just said the numbers 250 and 45. And then here are respective angles of these measures. Well, in the previous problem, what they would have done, or not problem, but previous videos, we would have seen problems where they said, let's let the vector A be the first one, so the 250 and the 25 degrees, and we'll let vector B be the other one, the 45 pounds, with the 250 degrees. Maybe I should have picked numbers that weren't the same, so it feels a little weird seeing 250 show up twice. They're different things from different vectors, so don't let that bother you. If you look at it this way and you go, well, look, here are two vectors. They gave us the magnitude and direction of both, and they asked us to find their combined force in the form magnitude and direction. So it wants these things. This is very much just the same thing as the last video that I put out, where we added together two vectors that were given with magnitude and direction. So we're going to go in then and just say, well, look, in order to combine them, it would be good to find the A broken down into the x and y components. It'd be good to find the B broken down into x and y components. And this is just really pretty repetitive. I mentioned that in one of the previous videos. These become very repetitive. We're going to have 250 cosine of 25 degrees. This is how we're going to go through figuring out our components. Over here, we're going to have the 45 instead of the 250 that's here, and the 250 instead of this 25. And so that takes just a second to write down, and it does take a little bit to combine by hand as well. But the nice thing here is there's nothing too crazy going on. We're not asked to find angles or anything of that nature beyond what we'll have to do at the end of the problem. Like they gave us everything to work with here. And so I'm just going to grab a calculator at this point, and we're going to go and get these values. Now, I want to point out that I'm going to save myself some time. First, I'm going to check my mode. So this has been reset, so I'm going to go and change that back to degree mode. I know I want to find the combined forces. So when I type this into the calculator, what I'm going to do is instead of worrying about the individual value, instead of finding AX up here, what I'm going to do instead is I'm going to go ahead and add to that my BX. So I'm going to go ahead and type in 45 cosine of 250. I already know I want them added up and combined, so let's just do it this way. And let's go ahead and just go 2 decimal places. It didn't specify, so that's okay. So what I'm going to see here is that A plus B is going to be 211.19. And then I'm going to do the same thing for the Y component now. Just making sure that we're careful to plug everything in correctly. We get 63.37. Now it's worth going in and just double checking and making sure everything you did before was plugged in correctly. So what you're not quite seeing me do here, because I was off screen a little bit, is I'm just scrolling back through and just verifying that these guys were typed in correctly. So here, I need to be careful because I accidentally hit enter on both of these, didn't I? That's okay. All right, so that was just me verifying that I typed things in correctly. And then what I want to do from here is just take these values and do what I've done a few different times in previous videos. I want to find the magnitude because it did ask for that back up here. It said find magnitude and direction, so it's not okay to leave it in component form this time. We'll take the square root of each component squared and added together. We'll find that in just a moment. We also are lucky that we ended up with two positive values because when I go to find my direction, my angle, I know that in the first quadrant with this double positive, all I have to do is inverse tangent of the y component divided by my x component. And that's really nice because I don't have to do any kind of like add 180 or add 360 or any kind of manipulation. I will get the answer that I'm looking for here. So let's figure these out just real fast. So square root of 211.19, square that, 63.37 squared. We're seeing about 220.49 for our magnitude. And then let's go and get our second tangent here. We'll go into our 63.37 divided by 211.19. I'm trying to work through this fairly quickly to save you some time, just to show this. So here are our two values. And so all I'm going to do is say that a plus b in this case is going to be the 220.49, 17 degrees. And there you have it.